Assalamu alaikum, and now we are resuming our lecture. So it's 25 minutes lecture, and where I'll continue. Those who can attend is good, but otherwise you can always get onto Facebook and watch the lecture. So we are discussing something very important. That is about the whole reason of performing Z transform. And as I mentioned earlier, that the whole purpose of performing Z transform is to find out about the stability of the system. Stability of an IR system. We never worry about the stability of FIR system. So IR system usually is represented with a difference equation. And we have seen this difference equation in chapter number 2 as well. And we are also dealing with this difference equation, though it's a first order difference equation in our modeling project where we are modeling the coronavirus. And as a matter of fact, you can model the coronavirus perhaps a bit more accurately if you increase the order of the system, maybe a second order, because sometimes it is not exponential, it is going a little down and up and down. So maybe a higher order system may give you better results. So the stability is important, and in stability we establish that we need to plot all the poles of the transfer function. So this is called a transfer function. So we need to plot all the poles of the transfer function. And how do we get transfer function? Simply the coefficients of B on one side are in the numerator and coefficients of X in the numerator and coefficients of Y are in the denominator. So it is that simple to get writing the transfer function is a very simple job. So in short, we can write that H of Z is equal to Y of Z, X of Z, and we can write it in summation form as well. K goes from 0 to M. B of K, Z minus K, as the first coefficient is always 1, so you can write it outside and write this as from 1 to N, A of K, Z minus K. Okay, so the difference equation that we have seen now is written as a transfer function. So okay, so we know the transfer function. The next thing we need to do is to find roots of the denominator and roots of the numerator. Okay, so that's also very simple, that you have roots. Sometimes you may end up having some constant, but as you know, roots are written in the product form. That if there are m roots, so it will be roots like 1 minus ck z minus k. And the poles are k is equal to 1 to n, 1 minus dk z minus k. And we need to find out, so these are the poles, okay? These are the poles. This is a pole. And we need to find out the pole that has the maximum magnitude. So you may want to write as Z magnitude is, because outside the outermost pole, the pole that has the maximum amplitude. So remember drawing the circle with red color. This is a unit circle. This unit, why? Because it is R is equal to M. This is a very important circle, and now you plot all the poles. If all the poles are in the unit circle, and how do we figure this out? Find out the pole with maximum magnitude. Let's say this is the pole with maximum magnitude, and see if its magnitude is less than 1. This condition says if Z magnitude has to be greater than for the region of convergence, and if check this magnitude is less than 1 or not. So if it is less than 1, you declare system as a stable system. So now going from the difference equation, constituting a transfer function, converting the transfer function into poles and zeros, and finding the pole with maximum magnitude will answer the most important question while dealing with IIR systems, that whether your system is stable or not. Let's do an example that will also make us appreciate it more. So once you are implementing, designing, as I mentioned earlier, that you are only worried about the difference equation. Let's say difference equation is given to you, y of n minus 3 y of n minus 1 plus 2 y of n minus 2 is equal to x of n plus 3x of n minus 1 plus 3x of n minus 2 plus x of n minus 3. So usually in signal processing, and especially if you go work at any place, you will be only dealing with a difference equation, and it is very simple to implement a difference equation. How? All you get an input. Okay, you have previous input, previous to previous input, previous to previous to previous input. You have the previous output and previous to previous output. Right? So you would just multiply these, add them together, and this you bring on the other side. So you get a y of n. Once you get a next input sample, your x of n becomes x of n minus 1. So the new sample is x of n, and your y of n, which you calculated, becomes y of n minus 1. So it's very simple. Writing a program for this, it may take you just 5 to 10 minutes if you're a good programmer to write a program to implement this. But this equation does not tell you whether it is a stable system or not. Okay. So before you implement any system, you need to check its stability. You only implement a system if a system is stable. Sometimes you design the system yourself, or sometimes you are modeling. Okay, for example, you are modeling the environment, the channel, and you want to make sure that once you are modeling, interestingly, if I tell you our human voice. Okay, let me try to draw this person. This is a person, yeah. These are his here. So people have modeled the process of voice production. Very interesting. Process of voice production as 10th order IIR system for about 256 millisecond to 512 millisecond or less. They say that you can model the voice, the speech I'm delivering as an output of an IR system. Okay, and that's how speech compression is achieved. Speech compression, you never send the speech, you send actually a difference equation, and the other side take this difference equation, and usually input is an impulse. So you or input has to do something with the pitch of your voice, which is detected. So you reproduce voice. So once your mobile phone or your Skype or your Zoom is sending voice, it is not sending voice. It is sending a difference equation. Okay, and the receiver side, and that's how you save the bandwidth. And same is the case with MP3 songs. So the voice is modeled as a 10th order IAR system, and at the receiver it takes the coefficients, the 10 coefficients, and then it produces voice for you. So but before the transmitter transmit, it must check the stability of the system. so that it must produce voice, otherwise it may produce noise. So checking the stability is very, very critical. And in this case, you have to compute stability of every 256 milliseconds. So you capture voice, model it as you are modeling using a first order, speech is modeled as a 10th order system, almost the same. So you are only finding coefficient A. I asked you to find coefficient A. For speech, they have to find out 10 coefficients, which is A1, A2, A3, A4, and it's a zero all pole system, and there are no zeros in the system. So, and then once you have the system, you check its stability. If it is stable, then you transmit. So checking stability is very important. So how do you check stability? For example, here, first of all, you need to find out the transfer function. The first thing is you need to know the transfer function. Writing transfer function is very simple. We have already established that coefficients of the numerator will come in the coefficient of x will come in the numerator, coefficient of y will come in the denominator. So you put coefficient 1 plus 3z inverse plus 3z minus 2 plus 3z minus 3. This, and then coefficient of the denominator, which are these 1 minus 3z inverse plus 2z minus 2. So this is how you write the transfer function. So from here to here you can just come and do this, and now you need to find roots. So there is a function in MATLAB which you can use to find roots of the numerator, and otherwise it's a little cumbersome process to find, though it's in this case this is just a formula. Sorry, there is no 3 here. There is no, yeah, it is 1. So if you find out the roots, okay, so the roots of the system, you will figure out that these are actually 1 plus z inverse raised to the power 3 divided by 1 minus z inverse 1 minus. So this is what is meant once I say you need to factorize. Once you are factorizing, so factorization would take you to primarily write the polynomial in terms of factors, which you must have done in your high school algebra classes, that how to make, remember, like it is, you make factors of this. So these are the 2 factors. So what are the poles and zeros? We know that it has a pole at 1 and a pole at 2 and 3 zeros at minus 1. Okay, so you need to draw these. So how do you draw this? So you plot and draw this. Let me plot this. So there is a pole at 1, and you right away you know that this is an unstable system. A pole at 1 means you are done with, because the unit circle has a pole, means whether it is a left hand side or a right hand side sequence, this can never be stable. Okay, so you say, oh, so it's a pole, so it's not a stable system. One pole here and the other pole is at 2. Other pole is at 2. And there are 3 zeros at minus 1. Remember, it is 1 minus AZ inverse, that's why it's a plus sign. So we say at minus 1 there are 3 zeros. And draw the this is your drawing. Unit circle, draw the unit circle. And now you know whether if it is a right hand side sequence. So we know the region of convergence is outside 2. If it is a left hand side sequence, region of convergence is inside 1. If it is a two-sided sequence, region of convergence is between 1 and 2. So in all these three cases, this system is unstable. This system is unstable because of the pole right on the unit circle. So unstable system. All cases you don't need to even. It's an unstable system. Okay, this is an unstable system which usually you don't like. So okay, this is one part. So whenever we are given a difference equation, finding out the roots, and remember for speech you need to find out there is a 10th order polynomial. This is a 10th order polynomial. So there are very interesting techniques people have devised, because you have to do this in real time. Factorizing a 10th order polynomial is quite a task, but thanks to there are people like Levinson and Durbin and who have come up with the recursion that helps you to basically finding all the poles of the system. So this is an unstable system. Okay, so stability, and this is how we check the stability. Now let's discuss how do you find the inverse Z transform. That's also important. Not really important from practical perspective, but it is important from the course perspective. In otherwise, in real life, once you are dealing with signal processing, you need not to perform inverse Z transform. You are good enough. If you do this, you are done. Okay, you are done, because you know the poles are outside the unit circle. Because if you think about the inverse Z transform, you are not interested in inverse Z transform. So why I made that statement that we are not interested in inverse Z transform? Because what inverse Z transform will give you? You have an h of Z, okay, which is a transfer function which has roots and a polynomial in the numerator, polynomial in the denominator, okay? And if you take an inverse, you get an h of n. H of n for an IER system is an infinite impulse response. Neither you can store it in your computer, because you cannot store an infinite sequence in a computer memory, okay? Nor you can use convolution summation to implement a system. So that's why practically we have zero interest in finding the inverse Z transform. But for the exam, definitely you are going to get a question. So we need to learn how to compute inverse Z transform. Okay, inverse Z transform, the best way, like we did in the Fourier transform, the best way is remember the pairs and the properties. So otherwise, finding inverse Z transform is very difficult, because inverse Z transform requires you to solve a Cauchy integral. I remember once my instructor, Georgia Tech, was teaching us this. He actually solved, he took like 1 hour to solve a simple inverse Z transform, because it requires you to know about Cauchy integrals. It's a very ugly looking formula which says 1 over 2 pi j, and this is Cauchy integral C x of z n minus 1 dz. So nobody can actually, an engineer would hate to spend an hour to find out a simple Z transform, an inverse Z transform. So nobody actually uses the formula. They may be mathematicians who learns about these Cauchy integrals and they try to solve this, because we need not to, because in signal processing we are only concerned with a very simple sequence, and that simple sequence is h of n is a of n, u of n. And from the course perspective, there is another sequence which is minus a of n, u of minus n minus 1. Okay, so we are only interested in this sequence, and maybe delta of n minus d, two more, but not more than these. And I know that Z transform is a of n, so Z transform is 1 over 1 minus a Z inverse Z magnitude is greater than a magnitude. And its Z transform is same, but region of convergence Z magnitude is less than a magnitude. And its Z transform is 1, and its Z transform is Z minus D. So if you know only this, you can solve any question in the exam, almost any question in the exam, which talks about finding the inverse Z transform. So let's do an example. If you are asked, so an example here, that if you are asked to find inverse Z transform of 1 over 1 minus 0.3 Z inverse, okay, into 1 over 1 minus 0.2 Z inverse. Inverse Z transform for these two. What do? So you first need to find out the partial fraction. So make partial fractions, and so let's assume you have something, so you know how to make partial fraction, right? So you hide this, you apply this here, and then you apply this here. So that's how you actually can compute the partial fractions of an expression like this. So its partial fraction A is going to be 1 over 1 minus 0.3 into 0.2, and B is going to be 1 over 1 minus 0.2 into 0.3. So same, you're going to see the same coefficient. So hide this, put the value here, hide this, put the value here, will give you the value of A and B. And that's how the partial fraction works in. But you can go through the lengthy process as well, but it's just a simple trick of finding the partial fractions. So you have some constant, let me say 0.4, which is not correct, okay? You need to find out what the value is. Instead of just wasting time, I'm writing it. And then same here. And now you need the pair. So pair says, so there are two poles. One is at 0.2 and 0.3. So for this you are going to have how many possibilities? 3 possibilities. One is both right hand side sequences. So it is 0.2 n u of n plus 0.3 n u of n. Okay. So region of convergence is outside this. Both left hand side sequences. So this is the answer is h of n is equal to minus 0.2 n u of minus n minus 1 minus 0.3 n u of minus n minus 1. Okay, and the third is right hand side and two-sided sequence. The two-sided sequence is inside a ring like this, 0.2, 0.3. Okay, so h of n is 0.2 n u of n minus 0.3 n u of n minus 1. That's all. Okay, so I have told you the partial fraction trick. Partial fraction trick is very simple. Like if you have 1 minus 2 z minus 1 and then you have many factors, 1 minus 4 z inverse, 1 minus 5 z inverse, 1 minus 6 z inverse. So this factor you put 4, hide this, put 4, you get A. Hide this, put 5, you get B. Hide this, you put 6, you get this. So partial fractions A, B, C, you can, no matter how many partial fractions are there, you can find partial fraction like this. So now we know that usually this is how, or sometimes you may need to use properties. Like if I have already solved this, but if it says Z4 1 minus 2Z inverse, this is an example. And here you know that you need to apply the delay property. First you say 1 over 1 minus 2Z inverse, and you say it is Z inverse is 2n u of n, especially if I tell you that Z magnitude is greater than 2. You know it is a right hand side sequence. Now Z4 multiplying by Z4 simply means that every n will be replaced by n plus 4 un plus 4. So it's that simple. Then is what if डॉक्टर अली को नहीं मालूम था, सॉरी टू, आई शुड हैव टोल्ड हिम कि हम क्लास कराने लगे 3 बजे. ही एक्चुअली कॉल्ड एंड नाउ ही इज ऑनलाइन एज वेल. So we are almost done. Last minute. So usually in exam you get a question like this. I have solved this for the Fourier transform. Remember, you need to write first a 2 in terms of n plus 4. So you write n plus 4 minus 4 un plus 4. Okay. Then you take this 2 raised to the power minus 4 out. So now you have 2 n plus 4 un plus 4. And then you actually use this. First you solve this, which is primarily answer is this. Okay, this is the answer for this. But now you need to multiply with 2 minus 4 both sides to get to the. So this is how you actually ख़त्म हो गई है क्लास. जी क्लास ख़त्म हो गई, अभी ख़त्म हो गया, 3:25 हो गए. तो थैंक यू वेरी मच. इंशाल्लाह नेक्स्ट टाइम हम एक ये कर सकते हैं, इफ़ यू नीड लाइक सम मोर इंटरएक्टिव सेशन वे वी कैन जस्ट यू कैन आस्क क्वेश्चंस. तो हम जूम पे भी एक कोई हम इंटरएक्टिव सेशन अरेंज कर सकते हैं फॉर यू टू आस्क क्वेश्चन. वो मुझे बता दीजिएगा. वी हैव नाउ अ लाइसेंस ऑफ जूम वेयर वी कैन 100 people कैन be in the conference at the same time. So next time we plan an informal session on Zoom. Or walaikum assalam. Sorry you were calling me, so I was just. तो बस ये क्लास ख़त्म हो गई है, तो हम अभी अपनी मीटिंग करते हैं. थैंक यू वेरी मच एवरीवन. स्टे सेफ, कोरोना से बचें बहुत ज़्यादा. खुदा हाफिज़. MS Teams assigned deadline extended. Yeah, I think इन्होंने डेरिवेटिव वाली एग्जाम्पल पूरी भेज दीजिएगा. या I'll send you the derivative example. मुझे लगा था लोग डर गए थे उससे, so today I skipped that example, but I'll send you the example इंशाल्लाह. तो और कोई किसी का क्वेश्चन हो तो पूछ सकता है. अल्लाह हाफिज़ जी. थैंक यू वेरी मच. खुदा हाफिज़.